Hey guys, now that we're done with angle relationships, we can start moving on to the next thing on the list, which is the Pythagorean theorem. And I wanted to show you an activity that we would have done in class. This activity probably would have taken a day and a half just to make all the pieces. But I have them all pre-made, so I'll just show you what we would have done. The first thing I would have had you do, is make a right triangle. As you saw in the last video, the Pythagorean theorem is something that only works with a right triangle. So as you can see right here, I took a piece of orange construction paper and I laid a ruler somewhere on that, randomly on that piece of construction paper. I drew a line right here, and this corner right here is just the corner of the construction paper. So I know this is a perfect 90-degree angle because the machine made it. And then I just created the triangle just by making a random line. So you guys would have made some random lines as well. Your triangles would have been all different. We would have had some medium size, some large, some small, some very scalene, some very scalene. You could have even made an isosceles one. A lot of different ones would have been made. It would have been really cool to see all the different kinds that we could make. But in the meantime, we're just going to work with this one. So you can see I labeled everything. We know that the legs right here are marked A and B, and then the hypotenuse right here is labeled with a C. And what we're going to do is we're going to make squares come off of each one of these legs and for the hypotenuse. So this would have taken a little bit of time. But I have to find this length right here, length A, and make a square out of it. And that's what I did right here with this piece of construction paper. So you can see it's the perfect length A right there. If you can turn it here, you can see the perfect length of A right there as well. So it's a perfect square of length A, and we're making that come off of leg A. Now if this has got a length of A right here and it's a square, that means this has got a length of A. That means the area has to be A squared, because A times A is A squared. Alright, we're going to do the same thing with leg B. So this would have taken quite a bit of time. All the constructions we would have had to done to make sure that this was a perfect square coming off of B. But that's it. You got a length of B there, a length of B there. When you multiply both of those together, you get an area of B squared. And then finally, you've got the hypotenuse. So I wanted to build a square off of the hypotenuse. That's got a length of C. This also has a length of C, making it a square. C times C gives you an area of C squared. Alright, where did I put that? There it is. Alright. So at this point, what I would have shown you is what the Pythagorean theorem is. Okay, the Pythagorean theorem says that A squared plus B squared is equal to C squared. So if we do this using an area model, what the theorem is actually saying is, let me get this guy out of the way, is that if I take these two pieces right here and I cut them in a certain way, they should land perfectly right on top of this one, because A squared plus B squared should be equal to C squared. So I want to show you, we would have done the same thing here in class, but I want to show you how I did this. I've already cut the pieces up for A squared. Whoops, let me move that over a little bit. So usually this would take this, there's a little bit of a trick to cutting this the right way. But I wanted to show you. Let's see. There's piece 3. No, that would have been on the inside, like that. And then 2 goes right there. And then the 1 goes right there. And then the 4 goes right there. All right, so I wanted to show you that this piece right here that I've already cut up into pieces is the exact same size as a squared. So let me take the other a squared and pull that out. There we go. All right, so I want you guys to see that we still have a squared here, we still have b squared here, and we still have c squared here. Let's go back to the Pythagorean theorem one more time. It's saying that a squared plus b squared is equal to c squared. So the area of A and the area of B should fit perfectly right on C. And I've cut this in such a way that I can make that work. Watch this, it's pretty cool. Alright, I purposely cut these into right angles right here so I can put them in the corners. So I'm going to put the 1 right there. I'll put the 2 right there. And the 3 goes perfectly right there. Look how that fits perfectly right on top of there. And then watch this one. This piece right here fits perfectly right there, leaving the square right there, and voila, you've got b squared fits in there perfectly, just like a puzzle piece. So you can still see the tan part of the c squared underneath it. That's just some human error right there. So if you take a look at some of the other links I have on Schoology, you'll be able to do this whole thing digitally. It's a lot of fun to do it with construction paper. I really wish we had the time to do that, but I'm going to have you guys do that digitally. So if you move on to the next thing on Schoology, you'll have a few digital puzzles that you can play with. All right? See you there.